So we continue, right? So you can see here, right? The characteristic of the image. So the image is formed in front of the mirror. Okay. So I already told you last lesson, right? So in front of the mirror is this side. Okay. So this is called as a real. Okay. So the image is real. So it formed behind the mirror. So this one is called virtual, right? So since its image formed in front of the mirror, so this one is real. The first characteristic is real. Okay, and then you can see the image is going down like this. The arrow is going down. So this one, this is inverted, right? So inverted, and then number 3. So the size of the image is actually same size of the as the object. Okay, same size as the object. Okay, the object and the image we have the same size. Okay, so this is the 3 characteristic for the concave mirror. If U is equals to F, means the object is at C here. Okay, alright. So what if the object is situated between F and C? Okay, so this is the object. So still the same way. Okay, you draw first one from here to here. Okay, and then since the mirror use the reflection, so it will reflect back to F. Okay, so it will reflect back to F. So it will reflect back to F like this, and then go back to F, right? And then the next one, okay, the next one is from F, from the arrow there, then go down. Okay, you don't have to make it longer, right? So the image will be here. Okay. So the characteristic is first one is inverted. Okay. You can see the arrow is going down here. So this one is inverted. The image is inverted, and the image is situated at the in front of the mirror. So it's real. Okay. And then the next one, the last one is a bigger than the object. Okay, bigger than the object. So this one you have to use a ruler lah. Make sure you use a ruler to draw the ray diagram. So bigger than the object. Okay, so what happens if the U, okay, if U is equals to F, okay. So if U is equal to F, right? Wait. Okay. So if U is equals to F, how you want to draw it? Right. Okay, the first one, same way. Okay, from here, from the object goes here, and then reflect back to F like this. Okay, right. And then the second one, right? Because you cannot, because you know this one you have to reflect back to F, and then this one they have still to pass through the F and reflect it back, right? But this one cannot because the F is here. Okay, so what you have to do from C, okay, from C you underline it until it pass through the arrow there. Okay, then just make it longer. Okay. Okay. So as you can see, there is no image form here. Okay. So there is no interception here because this one they got the interception, right? But this one no. Okay. So means the image is at the infinity. Okay. So we don't know where. So if you make it longer, so they will not intercept each other, right? So the image is at infinity. Okay. The image is at infinity, and this one, okay, the image will be formed, okay, behind the mirror. So this one should be visual. Okay, so image at infinity, okay, and then visual. Okay, so if make it longer, you can see the image is bigger. Okay, bigger than the size of the object. So 3 characteristic. Okay, so 3 characteristic. The first one is image at infinity. Okay, and then is it visual? okay, because it formed in this side, okay, and then it's bigger than the object. Okay, so that is a tree image of the U is equals to F, right? Right, next one. What if, okay, what if the image is smaller than F? Okay, means it is situated before the F. The object is before the F. Okay, so same way, okay, you have to draw it. Okay, okay. So first one, same from here, go back to F. Okay, right. So for this one, same that before, the U is equal to F, right? Same that before this one. So just draw, okay, until it pass through the arrow there. Okay, and then make it longer. Okay, right, make it longer until it intersect each other. Okay, so this one you can see it intersect here, right? So the image is visual, okay, visual, right, and then bigger than the size of object, okay, and the last one is upright. Okay, you can see the image is upright. Okay, so I repeat again. So the image is formed behind the mirror. So this one is visual. Okay, and then bigger than the size of the object, right? And then the last one is upright. Okay, so that's how you draw for the concave mirror. Right. So the next one is for convex mirror. Convex mirror has only one ray diagram. So means wherever the object is, the way to draw is the same. Okay. So the first one is from here. Okay, from here. Okay, so goes here. Wait. Okay. Can you give me like 1 minute? Okay. Sorry, class. Okay, so we continue. Okay, from here, go here. Okay, so right, and then the next one, okay, you make it this line longer, so it reflect back, because you know that the convex mirror is a reflection, right? So it's like reflect back, so it's like this. Okay, from here, okay, make it line here first, then make it longer. Okay, so and then the second one, okay, then we use C here. Okay, so it means you have to add one more, 1, 2, 3, 4. So this one is C, right? So the next one from here goes to C. Okay, right? So this is the image. Okay, so that is the image. Okay, so the image is visual, right? So visual smaller than the object. Okay, and then the last one is upright. Okay, so that's how you draw for the convex mirror. So even that the object is here, okay, let's say before F, the way to draw is the same, okay, because only one way to draw ray diagram for convex mirror, but only for concave there has many cases, okay, so it depends where is the object, right? Okay, and then the next one, okay, so we see the application of mirror, okay. So the plane mirror, usually the plane mirror, right, used in the optical testing, okay, mirror in emitter, okay, or voltmeter. So there's a pointer there, so below the pointer there will be like a mirror, okay, a curved mirror like this. So that one is actually a plane mirror. So what is the function of the plane mirror? Okay, behind, at the emitter. So that one is to avoid parallax error. So is to measure the image of the pointer directly below the pointer itself. So when you read, you have to make sure that your eyes, okay, and your eyes can see the image of the pointer and the pointer itself. Okay, it will be like intersect each other like that. Okay, like be parallel in each other. Then you can read. Okay, so this one is to avoid the parallax error, and also we use it as a periscope, right, or the kaleidoscope. This one is for total internal reflection. Okay, but you cannot use the plane mirror directly. You have to cut it, okay, to prism. Okay, so to prism, then you can use it in the periscope, right, or in a binocular, okay, to form the total internal reflection. Okay, for convex mirror, okay, so we use the convex mirror, okay, because the wider field of vision. So this one we use as side mirror of the car, okay, surveillance mirror or blind corner mirror. Okay, so let's say there's a corner, they will put corner on the road, right? So they will put the convex mirror there. So you can see when the image of the car coming, okay, from the other corner. So this one we use it because it wider field of vision. Alright, and then for C, concave mirror, okay, larger than object. So this one is for shaving mirror, for dentist mirror, makeup mirror, and also for the bicycle headlamp. Okay. So it produces a parallel beam of light. So this is the application of mirror. Okay. Alright, the next one, okay, we see the refraction. Okay. Refraction. Okay, so refraction of light. So what is the meaning of the refraction? Okay, so the refraction is when the light is travel, okay, between the two medium, right, that has different density. Okay, so because of this different density, okay, the velocity of light will be different, okay, between the two mediums. So let's say the two medium between glass to air, right, or water to air, okay, or water to glass, okay, so it's different density, right? So when the light pass through it, okay, so there will the reflection will occur, right? So this is the reflection of light. All right, the next one, okay. All right, so there are two condition, right, for the refraction, right? So the first one is when the light travel from the less than to the denser medium, right? So the less dense, so let's say from the air to the water. So air is less than the water, right? So you can see here, right? So before that, I introduce first, right? So this one is a normal line. Okay, so this is called as a normal line. Okay, so from the normal line, okay, to the incident line, incident ray here, okay, this is called as incident angle. Okay, from the normal line, okay, to the refraction ray, okay, this is the angle here is called as the refraction ray, sorry, reflection angle, right? So you can see when it travel from the less dense to the denser medium, so the light will move towards the normal. Okay, so means the R will be getting smaller here. Okay, so it will move closer to the normal line. Okay, so the next one is when the light, okay, travel from the denser to the less dense. Okay, from the denser to the less dense. So you can see the refractive refraction ray is move away from the normal. Okay, so means the angle of the refraction R here become bigger. Okay, so this one you have to remember, right? So and then the next one, okay, so this is the formula that we usually use uh in the exam, right? So refractive index. So how you want to find refractive index? So there are three formula. So let's say if they use the velocity, so n is equals to c over v. Okay, c is what? C is the velocity of light in vacuum. So this one is actually a constant value, right? There is 3 times 10 power of 8. So means it's not change. Okay. Alright, for V, this one is the velocity of light in the medium. So it depends whether they use water or use air or glass. So that one usually they will give. So N is a refractive index. So this is the first formula. Right. So let's say for the question give you the angle here like this one, right? So N is equals to sine I over sine R. So I, remember, right? I must always come from the air. Okay, even let's say the refractive index, okay, like this, for like this example, okay, even the incident angle is actually water, right? I is here, right? But you have to take, okay, I is R here because I must always be in the, must always come from the air. Okay, so this one, the R here will be the value of I here. Okay, because I must always come from the N. Okay, so N is over sine I over sine R. Okay, so this is the second formula. So third formula is the using the real depth and apparent depth. So let's say there is a fish, right? So there is a fish here. So the real depth is from the surface of the water to the fish here. So this is a real depth. Okay, the apparent depth, so this is the image of the fish, right? So the apparent depth is from the surface of the water to the image of fish. Okay, so there we give you the length here. Okay, so you just have to divide. Okay, just remember real depth is from the surface of the water to the object here. So this one they use a fish. And then the second one is from the surface of the water to the image of fish. That one is called as apparent depth. So this is the three formula that you use to find the refractive index. Okay. So usually this one they will give in the exam, so you don't need to memorize. Okay. So now I think I give you the exercise before I go to the next topic, total internal reflection lens. Okay. Can you try to open the exercise first? Wait. I open for you. Hmm. Hmm. Wait, I find the exercise first. You can try to answer first the question. Okay, I show you this one. Okay, so I hope you already have this exercise with you. You already tried to answer this question. Anyone can answer? Did we already try to answer this question until which part? I forgot already. We already answered this question for objective part. I can't remember. Anyone remember? Can someone say something? Wait, I check first. I check first. Okay, we still did. Okay. Alright, so we still didn't answer the question. Right. So let's go to the first question. Okay. For the reflection of light. Okay, so this is the actually for 5M and 5E. I think they already got this question. Okay, I gave to you last year, I think, right? So diagram below shows student A and student B standing in front of a plane mirror at distance 2.5 and 4.5. Okay. So the question is, what is the distance between student B and the image of student A? So the plane mirror. So the characteristic of the image of the plane mirror. Okay. So the first one is laterally inverted, right? It's visual. Okay. Same size as the object, and also the distance between the object and the image is same. So that one is a four characteristic you have to remember for the plane mirror. Okay, so for this one, because they ask you about the distance, so actually the distance of the image of the student A here, right? Student A here must be same as the image of A here. Okay, must same with the object A here, the same distance. So this one is 2.5, so mean the image here should be 2.5 also. Okay, and then ask you the image, the distance between student B and to the image of student A. Okay, so from the plane mirror to the student B is 4.5. Okay, and then the image of student A here is 2.5. 5. So 4.5 plus 2.5, so you got 7 meter. Okay, so that's how you answer question number 1. Right, for question number 2, so it said diagram below shows a ray of light is directed onto a plane reflector. Right, determine the correct relationship between the angle of incidence I and the angle of reflection R. So you know that the rules, okay, the reflection, right? Reflections law. Okay, so the first one is the incident angle, normal line, and also the reflection ray. Okay, reflection ray, incident ray, and also the normal line must lie in the same plane. Okay, so I repeat, the incident the incident ray, normal line, and also the reflection ray, okay, must lie on the same plane. So that is the first law. Okay, the second law, the angle of the angle of incident angle, okay, must be same, okay, as the angle of the reflection. That means I is equals to R. So the answer is A. Okay, for number 3, okay, so diagram below shows a light ray entering and coming out from the black box. Okay, so for concave mirror, okay, concave mirror is known as the converging mirror. Okay, for the concave mirror, it is known as a converging mirror. But for the convex mirror, it's known as a diverging mirror. Okay, so means you can see here the light is diverged like this. So this one is called as a convex mirror. Okay, so the answer is C. Right, for number 4, okay, so convex mirror. Okay, so asking you where is the image form for the convex mirror. Okay, so you already know, right? The convex mirror only have one diagram, right? one ray diagram. So wherever the object is, the image will always be same. Okay, the way how you draw the image for the convex mirror is always same. So let's see, right? That we draw before for convex mirror. Think here, right? Yeah. Okay. This is convex. Okay. So you can see the convex mirror is formed before F here, right? So means for this question, right, the image will form at L. Okay. So the answer is C. Okay, so it doesn't matter where your object is, right? The image will always be formed, okay, with here at L. Okay, so the answer is C. So which of the following ray diagram shows the correct reflection of a light from a curved mirror? Okay, so this is a convex, right? I told you convex is a diverging. So this is wrong. Okay, this is converged, right? The ray is converged to one point. So A is wrong. Okay, and this is the concave mirror. Okay, so for concave mirror is a converging mirror. So mean it will focus in one point. So like this. So this one is actually for the concave mirror. Okay, the ray diagram for the concave mirror. This one is actually for convex mirror. Okay, so the answer should be C. Okay, so you see here there's a concave mirror. Concave mirror is a converging mirror, so it will converge all the light ray into one point. So this is the point. This one is called it as a focal point. Okay, this one. Alright, so next, the question number 6. Okay, so this is the plane mirror. So what is the characteristic of the image formed in the mirror? So I told you before, the first one is a virtual, same size of the object, and laterally inverted, and another one is also upright. So the answer is D, donkey. Okay. The next one, number 7. Okay, so diagram below shows a concave mirror. So concave mirror, so it said the distance between P and F. Okay, so between P and F is called as a focal length F. Okay, from here to here, this is called as F. Right, for number 8, which of the following ray diagram is correct? So this one is a convex mirror. Okay, so convex mirror, okay, remember the first line go here, then it goes to the F, then if you make it longer, okay, so it will reflect back here, okay, and then from here goes to C, right? So the image will be from here, okay, so the answer should be C, okay. Alright, so next one is a boy stands 2 meters from a mirror. He sees an upright image 2 times his actual height. What is the type of the mirror? Okay, for plane mirror, you know that the size of image is same as the object. Okay, so A is wrong. Okay, for B, concave mirror, okay, remember that when the U is like this one, I show you the ray diagram. Okay, like this one. Okay, so you can see this is the concave mirror. So you can see the image here, okay, is twice than the object here. Okay, so the answer should be concave mirror. If convex mirror, I told you there's only one way to draw the ray diagram for the convex mirror, right? And the image will always be smaller than the object. Okay, wherever the object is, the image will be always smaller than the object. So for this one, it only once the image is 2 times is his actual height. So means it's bigger than object. So only concave mirror that has the image that bigger than the object. Okay, for plane mirror, same size. For convex mirror, always smaller than the object. And for convex mirror, always smaller than the object. And for concave mirror, okay, they got a smaller one or bigger one, or okay, so but it depends on the object. Okay, where is the object? Okay, so only concave mirror that usually have the size bigger than the object. So the answer is B, boy. So let's see paper 2. So paper 2 diagram below shows an object in front of a mirror. Okay, C is the center of curvature of the mirror. So name the type of mirror used. So this one is actually convex, okay, not concave. This one is a convex mirror. Okay, so this one is very wrong. So this is a convex mirror. Okay, right. Calculate the focal length of the mirror. Okay, so from here is to here is C. So C is actually equals to 2F. Okay, C is actually equals to 2F. So C is 20 already given in the question. Okay, equals to 2F and F is 10. Just divide. Okay, so F is 10. So means this from here to here is 10 cm. And from here to here is 10 cm. So the total is 20. Right, the next one, complete the ray, diagram above by drawing one more ray from point X on the object to show the formation of the image by the mirror. Draw the image form. Okay, so they already draw for you this line. Okay, so for the next line is from here to here. Okay, then make it longer, goes to F. Okay, and then because you know the mirror use reflection, right? So it will reflect back here. Okay, so from here, draw to F. Okay, and then make it longer. okay, to show there's a reflection here. So mean that the line goes here, the ray light goes here, then reflect it back like that. Okay, then you just make it longer. So this is the image. Okay. So what is the state 1 characteristic of the image? So you can choose whether it's visual, diminished or upright. So remember, if the question asks you to give me only one, so make sure you give only one. Okay, not give like this one is actually for you to choose, right? But in exam, please don't do like this. Okay, I just give you the choice so you can choose which one you want. But for exam, only give one. Okay, because if you give like this, it means like you want the teachers to choose for you which one is the correct answer. So cannot. Only, let's say if you say one, only give one. If they want two, then give two. Okay, so just follow the instruction. Okay, right. For number 2, okay, for number 2, diagram A shows a candle is placed in front of a plane mirror. So a virtual mirror is formed in the mirror. So what is the meaning by the virtual image? So virtual image that cannot be seen on screen. Okay, so let's say if the question asks you what is the real image. So the real image is the image that can be formed in the on the screen. Okay, so virtual cannot be formed on the screen. Real can be formed on the screen. Okay, and then for question B, so in diagram A, complete the path of rays to show the formation of the image in the plane mirror. Okay, so the first one, they already give you the image here. So I make it longer, right? Because the line is not enough. Okay, so from here to here, okay, this is the given line. Okay, and then we draw, right, the line here, okay, within the center of the mirror here, so you know when the light will be reflected. Okay, so from here, so until it reach at the center, that I already make the line here. So until it reach here, it will reflect like that. Okay, and you know, because the reflection, the loss of reflection said the I must be equals to R, right? So from here, the angle here should be same. Okay, you just estimate, right? So from here, okay, and then estimate the angle, right? Make sure it's same like this one. Then you draw the line here. Okay, and for the second one also same from here, okay, until it reach the center of the mirror here. Okay, then you estimate the angle, make sure the angle is same, okay, and then reflect it back here. Okay, and then you just draw the image here, and you can see the image is the distance of the object here is equals to the distance of the image here. Okay, so this is the plane. How you draw the image for the plane mirror. Okay, right. The next one, state 2 other characteristic. Okay, so he wants the question wants 2, so you can put it upright. Okay, same size or same distance. Okay, same distance between the object, okay, and the image. Okay, and also laterally inverted. Okay, so that's thing 4. You can choose 2 from that. Okay, and then the next one. Okay, so this is the AC questions, right? Okay, so the first one is said what diagram A shows a phenomenon on flight on mirror P. Okay, and then diagram B shows the same phenomenon of light on Q. Okay, so it says CX is the radius of curvature and F is the focal point. So the first one asking you the meaning of focal point. So since this is a curved mirror, okay, So I already told you that curve mirror, curve mirror, this one is the convex mirror, right? So for convex mirror is a diverging mirror. Okay. So the focal point, the meaning of focal point for convex mirror, okay, so a point where all the light ray diverge from it. Okay, so you can see focal length from this, from the focal line, you can see all the ray is diverge, right? It diverge. Okay, so a point where all the ray, where all the light ray diverge from it. So it's from F, it diverge. Okay, the light ray is diverge. Okay, what if the question asks you the focal point, okay, for the concave mirror, okay, concave mirror, okay. So because the meaning for focal point for curve, for the convex mirror and for the concave mirror is different, okay. So this one they give you a convex mirror, so where all the light ray diverge from it, means from F, it diverges, the light ray is diverged. Okay, but for concave mirror is a converging mirror. Okay, it's a converging mirror. So if the question asks you the meaning of the focal point for convex concave mirror, okay. So this meaning supposed to be a point where all the light ray converge to it. Okay, converge to it. Okay, because you know that the all the light ray will converge into one point that they call as a focal point. Okay, so the meaning for the focal point for concave mirror is a point where all the light ray converge to it. Okay, so all the light ray will go to one same point. Okay, that the point we call it as F. Okay, so focal point. So a point where all the light ray converge to it. So that one is a meaning for focal point of concave mirror. Right, the next one is, okay, two cars traveling in opposite direction passing through a sharp bend. So a mirror is placed at X. Okay, so what is the type, what is the name of the type mirror at position X? So this one is a convex mirror. Okay, so this one is a convex mirror. Okay, because why? Because the convex mirror has a wider field of vision, right? Okay, so explain how the mirror is able to help the driver of R car to see car S. Okay, so the light ray from the car, okay, the light ray from the car is not Q, okay, the light ray from the car S, okay, is reflected by mirror to driver in car R, okay. So the light ray from the car X will reflect back to the car R, right? So then the driver will see the upright image of the car. Okay, the driver will see the upright image of the car S. Okay, in the mirror here, the convex mirror. And then the next one is the mirror has wider field of vision. So that's why we use the convex mirror, okay, to put at the corner of the road. Okay, there is a reflection, so the car, the light from the light from the car S will reflect back to R, so the R can see the image of car S here. Okay, so we use the convex mirror here because it has a wider field of vision. Okay, as a scout, you intend to design, right, a solar cooker, okay, that can be used to boil water using direct sunlight. Okay, suggest and explain how to build a solar cooker which can boil water in shortest time. So based on the following aspect, type of mirror used, the position, the material used for the cooker compartment, and the color painted outside and inside of the solar cookers. Okay, so this one you have to know, you have to answer in the table. Okay, use a table. Okay, so the next is the type of mirror used. Okay, so we use a concave mirror. So this one you can converge all the sunlight, okay, to the mirror, right? Okay, for second one is the put water container at the focal point. Okay, wait. Okay, and second one is to put water container at the focal point. So means all the light ray will reflected and focus at the focal point, at the one point. Okay. Okay, and then the next one is the material use. So the material that we use must have the low specific heat capacity. So mean it's easy to heat up. Okay, so just for the material for this question, okay, for this question, they ask you about what is the material used. Okay, please don't write the type of, please don't write the name of the material. So let's say if this one you know low specific heat, right? So let's say you use a metal, okay, or use a aluminium, okay. So don't put the name of the material. Put the characteristic of the material. So what is the characteristic of the aluminium? Because aluminium has a low specific capacity, it's easy to heat up. Put the characteristic of the material that you choose. Don't put the name. Okay. And then the next one is the color painted on the outside and the inside. So the outside should be black. Okay, so it can absorb heat. Okay, but for inside, okay, it should be in silver or should be a bright color, right? So the sun can be reflected back to the hookah. Okay, so this is the how you want to design a solar hookah, right? Okay, so let's see the next one. Okay, this one we already discussed. Alright, the next one is number 6. Okay, so shows the identical object located at different position in front of the identical concave mirror. Okay, so you see the object distance difference, the size of image also will be different. Okay, what is the meaning of real image? So before this, what is the meaning of virtual image? Image that cannot be formed on the screen. Okay, for real image, image that can be seen on screen. Okay, so that's the meaning of real image. Okay, and then this one for number 2 is the comparison. Okay, it's the comparison. Okay, for the object distance, the size of image. Okay, so the first one, compare the object distance. So you can see the object distance from diagram A is much closer, right? So the answer is object distance for diagram B is further or object distance for diagram A is closer. Okay, and then the size of image. Okay, so the size of image for diagram A is bigger. Okay, and then this and then they say relate the object distance and the and then the size of it and then the image distance. So the image distance for the diagram A is further. So this one you just use the diagram to compare, right? Right, and then the next one asks you to relate the object distance and the size of image form. Okay, so the further the object distance, the smaller the size of image form. Okay, and the last one asks you to deduct the relationship. Okay, between the object distance and the magnification scale. Okay, so for this one, the closer the object distance, the higher the magnification scale. So means the image form will be bigger. Okay, so the closer, okay, the closer the object, okay, see the closer the object to the lens, okay, you can see the image become bigger. So the magnification scale become bigger. Right, so if you answer the essay question, right, so please answer it like this in the point form. Okay, why? So it's easy for the teachers, right, to see your point here, so they will not miss any point. Because if you put it in the essay point, okay, So sometimes there must be like miss the point there, okay, one sentence there. So make sure you put it in the form so we know that 1 point is 1 mark. Okay, so please do it in this way in the exam. Okay. Okay, draw a diagram to show the image as shown in. I think this one is for another question. Yeah. Okay. Alright, let's see for 5.2, refraction of light. Okay, so what happened to the light as it travels from glass into air? So glass is denser, air is less dense. So denser to the less dense. So the speed of light will be increased, right? The speed of light will be increased, and also the angle of reflection also will be increased. Okay, denser to the less than means it reflected away from the normal. Okay, so away from the normal, I already told you the R will become bigger, right? So increase. The answer is B point. Right, the next one is diagram 2. Okay, shows a layer of oil floating on water. Which light ray in diagram below is correct? Oil is the less dense. Okay, water is a denser. So from the less dense to the denser, it will be refracted towards the normal. So towards the normal, you have to choose the closest one to the normal line. So the answer should be B, boy. Okay. Alright, the next one is diagram 3 shows a light ray moving from air into the glass block. Okay, so from the air into the glass block. So I already told you, they ask you to determine which one is the angle of incident, which one is the angle of refraction. So the angle of incident must come from the between the normal line and the incident ray. Okay, so should be here W. Okay, from the normal line and the incident ray. For the angle of refraction from the normal line to the refraction ray. So this one. Okay. So the answer should be D, donkey. Right, for the next question, okay, diagram below shows the depth of an image of coin seen when the coin is placed under a glass block, right? Calculate the refractive index. So this one we use the formula real depth, okay? Real depth divided by apparent depth, okay? So real depth divided by apparent depth. So N is real depth divided by apparent depth. Okay, I just use shorthand here. So the real depth is here, right? From the surface here to the object. So the object is here, so means 3. Okay, 3. And the apparent depth is the image. Okay, the image from here to the image, the length here is 2. So 3 divided by 2. So you got 1.5. So this is the refractive index. Okay, so the answer is C. Okay, for number 5, what is the refractive index of the glass block? Okay, so sine I over sine R. Okay, so the answer is sine A equal divide by sine B here. Okay, remember I must always come from the end. Okay, so the answer is A. Okay, the next one, number 6. Okay, ask you to compare the optical density. Okay, before I forgot, alright, the refractive index is represent the density of the object. So if the refractive index is higher, so means the object is denser. Okay, right. So we continue this question. So you can see here X and Z. Okay, so this one is refract towards the normal. So means X is less dense, this one is denser. Okay, for this one, X and Z, okay, so Z you can see refracted away from the normal. Okay, so means this one is denser to the less dense. So asking you to find the arrange the optical density for the medium in ascending order. So means from the lowest to the highest. So the lowest density is Z. Okay, because you can see it's refracted away, right? So means this one is refracted away, so this one is less than. So Z, okay, and then if we compare X and Y, okay, you can see Y is a denser here. Okay, so X is the in the middle, okay, and the highest one is Y. So Z, X, and Y. The answer is A. Okay, so the last one, question number 7. Okay, so number 7, if the fish at actual depth is 3 meter and the refractive index of water is 1.33, what is the apparent depth? So we use this formula, real depth divided by apparent depth. So refractive index is 1.33. Okay, and then the real depth is from the surface of water to the object is 3 meter. And the apparent depth you need to find. Okay, so we just divide 3 divide by 1.33. So you got 2.26. Okay, so last one, question number 8. Okay, so this one is the velocity of light in vacuum is 3 times 10 power of 8. So the refractive index of water is 1.3. So what is the velocity of light in the water? Okay, so this one they give you the velocity. So we have to use the n is equals to c over v. C already given to you. The velocity of light in vacuum is 3 times 10 power of 8. So this one is a constant value, it's not changed. Okay, like gravity, the value is always same. Okay, and then V do you need to find, and it give you the index of refractive index already. So you just substitute. So you got the answer B boy. Okay. So I stop until here. So we continue tomorrow. Okay. No, tomorrow, sorry, next week. Okay, we continue next week. Okay. I think next week we can do on Saturday. Okay. So thank you, class. Okay, welcome.